A titration calculation is something that we do once we've done our practical and we know that we've put a standard solution of a known concentration of one chemical and a known volume of that chemical, and we've reacted against an unknown chemical to find out how much is required to completely neutralize it or completely react with it. And if we've got those numbers, we might end up with a situation a little bit like this. We might have conducted titration. We might have reacted 25 centimeters cubed of 1 mole per decimeter cubed sodium hydroxide with an unknown concentration of hydrochloric acid. And we may then have found out that it reacted with 12.5 centimeters cubed of hydrochloric acid. And so we need the equation for the reaction, so that's good to write out there. We can, from this, calculate the concentration of hydrochloric acid. Now, there's a few things that we need to know first. The first thing is it's good to make sure that in any question that you see on this or any situation where you're doing this, you are very clear about which numbers are for which chemical. So here, the 25 centimeters cubed and the 1 mole per decimeter cubed both are for the sodium hydroxide. So to emphasize that, I've just done them in red. And then the 12.5 centimeters cubed for hydrochloric acid is in blue. Okay, now we have an unknown concentration of that, so that's what we're going to be calculating. Second thing is we need to know our conversion. So if I have a volume in decimeters cubed, then that is actually the volume in centimeters cubed divided by 1,000. Okay, so you'll see that my concentration was in moles per decimeter cubed and my volume is in centimeters cubed. Therefore, I need to make sure that I'm working in the same unit. And so I'm just going to keep that relationship in the box there. The third thing we need to know is that the number of moles equals the volume times the concentration. And here, the first thing that we're going to do, because we have the information, we have a volume of sodium hydroxide and we have a concentration of sodium hydroxide. Therefore, we can work out the moles of sodium hydroxide. The first thing we're going to do is we're going to calculate the moles of sodium hydroxide. So you'll note that as I've written this out, instead of just putting N equals V times C, I've written the chemical down subscript next to the letter I'm using for number of moles, volume, and concentration, and that's just so that I know exactly what it is that I'm trying to put in here. All right. And so I look for the stuff I highlighted in red. That would be 25 centimeters cubed, except we want that to be converted into decimeters cubed. So we're going to divide that by 1,000, so 25 over 1,000. And then we've just got 1.0. So if we plug those numbers in, we end up with 25 over 1,000 multiplied by 1 gives us 0.025 moles of sodium hydroxide which have been used. Now, if you have a look at the equation, there is no number in front of the NaOH, and there is no number in front of the HCl, which means that every 1 mole of NaOH reacts with 1 mole of hydrochloric acid. So, if that's the number of moles of sodium hydroxide, then we know that that equals the number of moles of hydrochloric acid which has been used, because in this case, number of moles of NaOH will be exactly the same as the number of moles of HCl, and therefore we can work out using this number here, 0.025, the concentration, because we know how much, we know the volume that we've used for the hydrochloric acid as well. So number of moles equals concentration times volume. If we rearrange that to make concentration the subject, we find that number of moles over volume gives us concentration. So concentration of hydrochloric acid, and you'll note that I'm using the HCl as a little subscript thing now because I'm talking about a different concentration to the one at the top of the paper. Okay, and it's clear, it's best for me to write that in so that you don't get confused. We can see that that equals the number of moles of hydrochloric acid, that being the same as the number of moles of sodium hydroxide. And we're going to divide that by the volume of hydrochloric acid that we've used. Now again, look, the volume is 12.5 centimeters cubed, so we're going to divide that by 1,000 to make it into decimeters cubed. And you can see that's why 12.5 is over 1,000 there. Okay, so 0.025 divided by 12.5 over 1,000 actually turns out to give us 2 moles per decimeter cubed, and that is the concentration of the hydrochloric acid that we've calculated from this experiment. It can get a bit more difficult than that. So if we have a look at a different question, okay, we've titrated 25 centimeters cubed of sodium hydroxide. This time the sodium hydroxide is of an unknown concentration, and we've got 1.5 moles per decimeter cubed of sulfuric acid. The sodium hydroxide is exactly neutralized when 12.5 centimeters cubed of sulfuric acid is used, and we've got our equation here. And we're asked to do the same thing. We're calculating the concentration, the unknown concentration, in this case, of the sodium hydroxide. So what do we have the concentration of? That's the sulfuric acid, and we have a volume for that as well. So we can use N equals C times V, number of moles equals concentration times volume, for the sulfuric acid. So sodium hydroxide I've done in blue this time, and sulfuric acid I've done in red. I'm going to remind myself that that's the conversion. And if we have a look, N H2SO4 equals V times C, both of H2SO4. So we take the red numbers, we take 1.5 moles per decimeter cubed, and we take 12.5 centimeters cubed. But we're going to convert 12.5 into decimeters cubed by dividing it by 1,000. So 12.5 over 1,000. That leaves us with 12.5 over 1,000 times 1.5, and that gives us a number of moles, which looks a bit like this: 0.01875 moles of sulfuric acid. Now with this equation, we've got to look a bit more carefully, because on the equation there are 2 particles of sodium hydroxide for every 1 particle of sulfuric acid. That means that if we have 0.01875 moles of sulfuric acid, we will actually have twice as much sodium hydroxide. That's twice as many moles of sodium hydroxide. So we're going to have to multiply that by 2. The number of moles of sulfuric acid multiplied by 2 equals the number of moles of sodium hydroxide, which is 0.0375, which is equal to the concentration of sodium hydroxide times the volume of the sodium hydroxide. So we are going to then just rearrange that equation again. Okay, number of moles equals concentration times volume. Therefore, concentration equals number of moles divided by volume. So we have the number of moles being 0.0375, and we're going to divide that by the blue number we have there is 25, but again it's in centimeters cubed, so we're going to divide that by 1,000 first to put it into decimeters cubed. We end up with this calculation here: 0.0375 divided by 25 over 1,000 equals 1.5 moles per decimeter cubed, and that is the unknown concentration of our sodium hydroxide. Key points: make sure that whatever you do, you convert centimeters cubed into decimeters cubed when you start the question. You can just write it in, convert it into the question in pencil or pen at the top if you like. Second thing, don't forget to just follow the procedure. You know, N equals V times C. Check that molar ratio, make sure that there's nothing that you need to do in the middle to make the number of moles change, and then N over V equals C. But again, everything is already converted into decimeters cubed at that point.